Hello, my friends. Dr. M is here to support your journey with financial economics as a part of principles of economics. And we are talking about intertemporal choice, the trade-off between future and present. So what we want to do is to come back to our previous last slide in the presentation where we specifically talked about the example that involves your right to choose between the two doors. One is $120 and the other one is $100. So suppose that interest rate is at 10%. And we considered last time interest rate at 20%, and we found that the two doors yield equal value, and thus you will be indifferent. Now, when interest rate is going to fall to 10%, you first have to calculate the present value of door number two. And as it was implied from the previous presentation, $100 is going to be the answer to this question because door number two gives you this amount right now. Thus, we have concluded last time that the present value of present goods is equal to their present amount. Now, the next thing that is left to do is to calculate the present value of door number one. And once you calculate present value of both options, then you can compare the amounts. So the present value of door number one when interest rate is equal to 10% is you take the future amount, which is $120, divided or stated in financial terms, discounted by 1 plus 0.1. And that is going to be $109.10 as we discovered previous slide. Therefore, you should take door number one when interest rate is equal to 10%. And here is the caveat. Because when interest rate falls, the present value of future amount rises. This is important. That's something that you want to take away with you because it's a fundamental principle for investment community. Let's take a look at what happens when interest rate is actually rising, and in this case to 50%. If it's rising to 50%, the present value of door number two from the previous presentation is still $100. It doesn't impact the present value because this good is presently available. However, when you are going to calculate the present value for door number two and number one, for door number one, it will be $120 divided by 0.5%. And in this case, your present value is equal to $80. Therefore, you choose door number two when interest rate is at 50%. It's a nominal interest rate and it's annual interest rate. Don't forget those two conditions that were implicit in this offer. Because when interest rate rising, the present value of future amount declines. That is important. So what you're looking at, two fundamental principles for investment community that where investors sticking to very religiously in order to realize the gains at the marketplace. Now we can move on and consider some simple but yet powerful rules in addition to what we have already discovered. Rule number one, consider two future amounts. Amount one is available 1 year from now. And you already know that implicitly tells you you're talking about annual interest rate. And amount two is available 2 years from now. What is the package? If you now want to calculate the package of both amounts combined, worth at present time, or simply stated, worth now, the answer lies in a series of simple rules. Rule number one, you take the present value of any future amount available or due n number of years in the future, and you can write it out as present value, which is P, equals to future denominated asset divided, or stated differently, discounted by 1 plus nominal interest rate powered n number of times. That is corresponding to the timing n. And we can unfold this, and algebraically that's what it looks like when you do this on the screen. Specifically, let's suppose that n takes value of 1, and this is what we have considered in the last two videos. When n equals to 1, then it becomes very simple. That's what we've been using in terms of annual interest rate and calculation. Now, when n takes 2 or 2 years from now, then you just substitute, and that's what you have in front of you on the screen. And finally, when you have many years, such as bridges, they are often calculated in terms of dozens of years that they provide the service. So there are some assets that are involving many, many more years, and even asset that has the implicit offer of payment forever. But we'll come back to this in just a moment. Let's go to rule number 2. The rule number 2 basically states that the present value of series of future amount is the sum or summation of the present values of those elements in the series. It will give you the following. If we will get something 1 year from now and 2 years from now, so we want to add up each independent argument in terms of their present worth. So originally, when I stated this question, talking about 2 years asset is available from now versus some other number of years, and we can have 311 number of years, then what you do is you find the present value of each of them. So you have an asset in front of you that is denominated 6 years from now. Nothing is available until 6 years from now. Then you have another asset that is available 2 years from now, and you have another asset that is available 311 years from now. So, and that's what you see on your screen. And in order to calculate properly, you will find the following answer. You have to convert independently each of this asset to present. Remember, we want to drive and convert each asset, so we compare apples to apples. And only when you discount it to present term, you are able to add up and calculate the present worth of the series of those payments. Let's do example. Example will help you to think through these rules. Joe Montana's salary contract, hypothetically, is offering $4 million a year for the next 3 years. A typical sports writer will tell you that the amount is $12 million. In economics terms, that would be incorrect, because if the interest rate is equal to 10%, then you actually come back and find that this contract is worth around $10 million. To be precise, $9,949,667.54. Because once you take $4 million that is paid 1 year from now and discount it to present value, it's no longer $4 million. Once you take $4 million that is available 2 years from now and discount it to present value, it would be worth even less. And obviously, once you do that for the $4 million available 3 years from now, it would be worth even less. So you can do this calculation based on the previous slide formula and come up with this answer on your own. Now let's go to the next rule, number 3. Consider an annual amount, asset A, that is the same, unchanged, every year. It's often referred to annuity. In fact, there is a product in investment community that is called annuity that specifically pays annual amount that is unchanged every year. Let's suppose this annuity lasts forever, making it a perpetuity. Basically, it's called perpetual annuity, a payment of the same amount that lasts forever. What is the present value of this contract? In general, annuity is an equal annual amount of money. Thus, you take asset A that is annually available to you based on the contract and is promised to be paid n number of years, and you calculate it as such as you see it on the screen. You're discounting that by 1 plus nominal interest rate powered n, and n number is number of years. Now, as n becomes a huge number, like as you approach infinity, as n approaching infinity, then summation term goes to 1 divided by interest rate. One divided by interest rate. Let's do example, and that will help you. Suppose this annuity annual amount that does not change is offered to you in sum of $100 with interest rate given 10%. What is the present value of this $100 per year forever? Remember, the first payment in the series is 1 year from now. So you take $100 and divide it by interest rate of 10%, and you will arrive to an answer $1,000. All right, and now we can make some powerful conclusions before we close this presentation. My friends, in general, if the interest rate falls, the present value of the future payments goes up. While if interest rates rising, the present value of the future amounts falls. This is very easily seen if you look at the previous slide when we considered perpetuity or annual payments forever. Moreover, higher interest rate lowers the present value of long-lived asset relative to the short-lived asset, while a low interest rate has just the opposite effect. If you were to use those rules that laid out before you, you should be able to answer the following questions. Number one, what is the perpetuity worth if the first payment is available today rather than a year from now? Number two, what is the perpetuity worth if it's delayed 1 year or 2 years or n number of years? And in fact, we have answered both of those questions already. And at that moment, I want to wish you a very blessed and healthy day. Thank you for your patience.